Hello everyone. Okay, these are the directions for question number 1 to 6. That is the set have 6 questions. Okay, so this set have 6 questions. So there are certain directions given here, right? And you can see that this set has 6 questions. Okay, and if there are 6 questions, right, generally you will like to solve the set first. Okay, there will be many questions based on the general things that you will calculate from the data, and then there may be some specific question based data. Okay, so the question which are based on data given in the question. Okay, so here let's say I've written the important thing here, right? One thing that was given right in the direction, you can see here that there are 4 bags. So Saral must put some different color bags, balls in some bags. So there are 4 bags, 1, 2, 3, 4, in which red, green, blue, white balls respectively are kept. So that means bag 1 is red, then green, then blue, and then white. Okay, so these are the balls kept in different bags. In each bag, balls of only one color are to be kept. At least one ball is there in each bag. Now this information we have written here also, right? At least one ball is there in each bag. So one thing that I know right from here, that the number of balls in bag n must be greater than the number of balls in bag n minus 1. That means that should be in increasing order. So if let's say bag 1, 2, 3, 4, right, containing balls red, green, blue, white, and number of red balls will be less than number of green ball, will be less than number of blue balls, will be less than number of white balls. So this should be the order, right? This should be the order. Okay, and now the condition is the green balls are at most 3, and it was given that at least one ball is there in each bag, right? And then the green balls are at most 3, more than twice the red balls. Okay, if I write the formula for here, so that means at most means less than equal to, so less than equal to 3 more than twice the red balls. Okay, so twice the red balls plus 3. So it is like this, right? The first condition says that the green balls must be less than equal to 2r, less than equal to 2r plus 3, where r is the number of red balls. Blue balls are at least one more than, that means greater than equal to thrice red plus 1. Okay, so this is the condition for blue balls, this is the condition for green balls, and here white balls are at most less than, that is less than equal to twice green minus 1. Okay, 1 less than twice the green. Okay, so these are the condition given, and the number of red balls is not more than 3. Okay, so that means red can be only 1, 2, 3, right? 1, 2 or 3 red can be. So if I take all the cases, okay, just see how I can take case. So if I write like in order, that is red, green, blue and white. Okay, so if I'm writing, okay, let's take another color. So if red is 1, right? So if red is 1, green can be, right, it is less than equal to 2r plus 3, right? That is given. So 2 into 1 plus 3. So it can be 2, 3, 4 or 5. Less than equal to 2r plus 3, right? This is the formula for condition number 1 is for the green balls. Green balls are less than equal to 2r plus 3. Now r is 1, so less than equal to 5. So green can be 2, 3, 4 or 5. Okay, let me write it like this, where red is 1. Okay, okay, I will tell you why I have written that gap. Okay, because I know that there will be multiple cases. Okay, let's see. Now if green is 2, right, see the condition number 3. Condition number 3, that white must be less than equal to 2g minus 1. right? Now white must be, right, in the first case, if green is 2, 2 into 2, 4 minus 1, white must be less than equal to 3. But see that red, green, blue and white should be increasing order. Now you cannot put any blue, so this first case is gone, right? That is wrong, that is not possible. Okay, now if I say in the second case, if green is 3, so 2 into 3 minus 1, that is less than equal to, right, 5. So it can be 5 and here it can be 4. So only possibility, less than 5 is not possible. So this one case is possible, right? 1, 3, 4, 5. Okay, now for the next, if green is 4, 4 into 2, 8 minus 1, 7. So less than equal to 7. It can be 6 or 7. Let's say 7. So it can be 5 here. It can be 6 here. Okay, 1, 4, 6 and 7. But white can be 6 also. So let's say 1, 4. Okay, I will write here 4 also. Okay, 5 I will take later on. So there is one more case for 4. So 1, 4, 5 and 6. So these are the 3 cases possible here for 1 and 4. If 1 I take, let's say green to be 5. Okay. So I have written these cases according to that third condition, that white. Okay, second condition I am not checking because blue is greater than equal to 3R plus 1, right? That is red is 1, so blue should be greater than equal to 4, and that is greater than equal to 4, right? Everywhere blue I am getting greater than equal to 4 only. Okay, that's why I am not checking this. Okay, now green if 5, then white can be 5 into 10 minus 1, 9, so less than equal to 9. So it can be, okay, let's say because it is less than equal to 9 in this case, so it can be 9. If 9, so it can be 6, 7 or 8 here, right? But less than 9, so it can be 8. If it is 8, it can be 6 or 7 here, right? Or if you take 7, right, if you take 7, then it can be 1, 5, 6, 7. That is also possible, right? So total number of cases for red equal to 1, right? So it is 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Okay, I have written all the cases, right? Now if red equal to 2, so I am moving to, because red can be 1, 2 or 3. So let's say if red equal to 2, and now that green can be, right, less than equal to 2R plus 3. So 2 into 2, 4 plus 3, 7. So less than equal to 7, right? So it can be less than equal to 7. So less than equal to 7 but greater than 2. So it can be 3, 4, 5, 6, 7. So it can be 3, it can be 4, it can be 5, it can be 6, or it can be 7, right? Now I will not write all the cases, but I will tell you how you can write. Now for blue, it should be greater than equal to 3R plus 1, that is 3 into 2, 6 plus 1. So greater than equal to 7. Now blue also, the condition is greater than equal to 7. That means here you can have only 7 or 7 plus, right? But white is less than equal to 2G minus 1. Now 3 into 2, 6 minus 1 is 5, which is not possible, right? Now white, because it is going to be less than equal to 5, so this is not going to be possible, right? So if I take 2, 4, right, you know that blue is going to be 7 or plus, but white is for, if green is 4, so 4 into 2, 8 minus 1, 7. So 7, 7, this is also not possible, right? That is, I am writing blue as a minimum, right? Blue I am writing minimum, white I am writing maximum. Okay, then still it is not possible. Okay, now for 2, 5, okay, the next one, if 2, 5, if green is 5, so white can be white can be, because blue is going to be 7 or plus, right? 7 or plus, or white can be now 5 into 2, 10 minus 1, 9. 9 or lesser. So it can be 8, it can be 9, or it can be 2, 5, 8 or 9. Because blue can be 7 or more. So blue can be 7 or 8. If it is 8, white can be 9 only. But white can be 9 or lesser. So if it is 7, it can be 8 also. 2, 5, 7, 8, 2, 5, 7, 9 or 2, 5, 8, 9. So 3 cases possible here. Right? If you take 2, 6. Right? If green is 6, then white can be 6 into 2, 12 minus 1, 11. So less than equal to 11. Right? White can be less than equal to 11. Okay? 11 or lesser. But here I know that blue can be greater than 7. So 7. So if I take 11 case, so here 7 to 10 possible. So 7, 8, 9 and 10 possible. 4 cases. So here I have 4 cases. So if I take 2, 6, now 2, 6, 10, because it is less than 10. So here I can have 7, 8 or 9. That means 3 cases. Right? So if I have 2, 6, less than 10, now 9. So here we can have 7 or 8. That means 2 cases. And if I take 2, 6, this as 8, so it is 7, so 1 case. Right? Okay, now come to 2, 7. Right? So I have written the cases of 2, 5, right? 2, 5 and 2, 6. Now 2, 7. Right? That is red if green is 7. If green is 7, now blue I know is a fixed 7 or more. Right? So that means here if green is 7, right, I am taking, yes, green is 7. So blue I can take 8 or more. Right? And white will be 7 into 2, 15 minus 1, 14 or, 7 into 2, 14 minus 1, 13 or less. So here would be 13 or less. So if I have written, right, 13 here, so it can go from 8 to 12. That is 5 cases. 8, 9, 10, 11, 12. Okay. If I take 2, 7, let's say 12 here, so it can go from 8 to 11. That is 4 cases. If I take 2, 7, let's say 11 here, right, so it can go from 8 to 10. That is 3 cases. And if you have 2, 7, 10 in the white, so 8 or 9, you will have 2 cases. Or if you take 2, 7, 9 here, so 8 here, so you can have 1 case. So total number of cases of, okay, 1 were 10, right? When red is 1, okay, when red is 1, the total number of cases were 10. Now when red is 2, the total number of cases are, right, here you can see 1, 2, 3, 3 and 4 cases, 7, 7 and 5, 12, 12 and 4, 16, 16, 3, 19, 19 and 2, 21, 22, 21, 22 and 6, 28. So we have 28 cases, right? Now we will see the cases for, right, when red is 3. Okay, when red is 3. Okay, let's take some other color. Okay, so that we can differentiate. Red is 3. If red is 3, okay, now green is going to be 2 into 3 plus 3. That is 2 into 3, 6 plus 3, 9 or lesser. Okay, you can have less than equal to 9. That means from 4 to 9. Okay, 3, 4, 3, 5, 3, 6, 3, 7, 3, 8 and 3, 9. Okay, this is red and green. Now if you have green as, okay, blue also you need to see that blue is greater than equal to 3 into red plus 1. Now red is 3, so 3 into 3, 9 plus 1, 10 plus. So minimum this can be 10. Okay, that is blue, minimum is 10. So 10 plus you will have. Okay, 10 or 10 plus. Now white is 2 into green minus 1, right? Green is, if green is 4, 2 into 4 minus 1. So that will be 7, not possible here because it should be increasing order. 2 into 5 minus 1, 9, so not possible here. 2 into 6, 12 minus 1, 11, only one case possible here, right? So this case is valid, right? Now here, into 7 minus 1, 2 into 7, 14 minus 1, 13. So here 13 is maximum, right? If 13 is there, right, now blue can vary from 10 to 12. That is 3 cases possible. If you have 3, 7, 11, 3, 7, 12 here, then 10 or 11, that means 2 cases possible here. Okay, and finally when you write 3, 7, right, 11, so here it would be 10. That means 1 case possible here. Okay. Now, if I come to 3, 8, right, if the green is 8, white can be 8 into 2, 10, 16 minus 1, 15. So 15 maximum. If 15 is there, so from 10 to 14, blue is possible. That is 5 values possible, right? If 14 is there, right, then 10 to 13 would be possible, right? 10 to 13. So that means 4 values will be possible. So like this 3, 2, 1, like here it will be 5, 4, 3, 2, 1, right? Okay, similarly when you go for green equal to 9, so white can be 9 into 2, 18 minus 1, 17. So 17, in case of 17, it can go from 10 to 16. The blue can go from 10 to 16, which will be 7 values, right? If this is 7, right, when you do 16, it will become 10 to 15. So the value will be 5, okay, sorry, 6. Okay, 10 to 15. If you take 16, so it will become 6. So 7, 6, 5, 4, 3, 2, 1. Okay, it will be like this. So total values now for when red equal to 3. Now when red equal to 3, I will have total cases, right? 1, 3, 2, 1, 6 and 1, 7, 7, 5, 4, 3, 2, 1, 15, 7 and 15. Okay, it is 22, 22 and 7, 6, 5, 4, 3, 2, 1. Sigma 7 is 28, 22 and 28, 50. Right, you can count these. So total number of cases becomes 50, 10 and 28. So these are the all possibilities, right? But this question was slightly lengthy because the first question on this set was the same thing, that is how many combinations are possible, right? And without doing this all, you cannot do, right? You can just, without writing, you can, if you get the logic that how you are getting those sets, right? Without writing few things you can do quickly. You may not write all the cases which I was writing initially, but still it is 50, 10 and 28. So total number of combination possible are 88. Okay. So now we will answer the questions based on this, right? When we know this, so how many different combination of the balls can be kept in the 4 bag? So this is 88. Okay. Okay, question number 2, right? We have already solved that set. What is the maximum difference between the number of white balls and that of green balls in any case that is possible, right? So any particular case, you need to see that the difference of white and green should be maximum. Okay. Now, when we have solved this, right, white and green maximum difference, right? So white and green maximum difference where the balls were maximum. Okay, just look at that part where the balls were maximum, right? Here green, okay, we need to see green are 9, so maximum here can be 17. So 9 and 17, the difference can go to 8. Okay, before that you cannot have that much difference, so here the difference is maximum 8. Okay, before that, if you are taking, right, let's say red as 2, if 7 and the maximum could be 11, so 4, so that means the last case where the maximum number of red balls and maximum number of green you have taken 9, there you are getting the maximum number of white balls also. So 9 and 17 here, the maximum difference can be 8, right? White and green, the maximum difference when white are 17 and green are 9, so the difference is 8, right? 8 is the difference. Okay, now let's move to the next question on this set. So what is the minimum number of green balls if the number of red balls is 3? Minimum number of green balls if the red ball is 3, right? I will again come back to that. Now red ball is 3, minimum number of green balls. Red is 3, minimum number of green balls are 6, right? When red is 3, minimum number of green balls are 6. Okay, so when you have solved this all, right, and now you can easily get all the questions correct, right, once you have solved that. Okay, so see here condition is given if there are no more than 9 blue balls. Okay, so blue balls can be less than equal to 9. Okay, then at most how many balls could there possibly be in all 4 bags combined? So when blue is 9, maximum number of balls together. Okay, when blue is 9 or less than 9 you can say, but here blue is 9, right? Just see, blue is the third one. When blue is 9, maximum number of balls, right? Because blue cannot be 9 in the last case. Last case when the red is 3, blue is minimum 10. Right? So blue 9 is possible here, right? When you have 2, 7, 9 and 10. Okay, so here 2, 7, 9 and 10, or here you have 2, 7, 9 and 11 also, right? Okay, or here you have 2, 7, 9 and 13 also. So the maximum that you have is 2, 7, this combination 2, 7, 9 and 13, right? This I think is the maximum possible, right? So that will become 13 and 7, 20 and 11, 31, right? 31 should be the correct answer. 2, 7, 9, 13 satisfy this condition. Okay, so it is 2, 2, 7, 9 and 13. So this is your red, green, blue and white, the combination that satisfies this condition, and you have the maximum number of balls. Total are 31. So your answer should be 31. Okay, what is the number of possible combination if the number of green balls is maximum? Number of green balls should be maximum, then the number of possible combination. Okay, green balls maximum. Let's come back to the solution. Green ball maximum. Okay, where green balls are maximum? Green balls are maximum at, okay, here it is 7, 8, 9. So green ball maximum are 9. Right? In the last case when we have green balls maximum at 9. Okay, when it was 9, the combinations were 7 plus 6 plus 5 plus 4 plus 3 plus 2 plus 1, that is sigma 7, and 7 to 1, the sum is 7 into 8 by 2, that will be 7 into 4, so it should be 28. Okay, so 28 should be the correct answer when the number of green balls is 9. Okay, when the green balls is 9, the total number of combinations you will have, right? Okay, actually it will be possible when the red is 3 and your green is 9. Okay, so this will be the case when red is green, this is the 3 and green would be 9. That is the maximum number of then blue and white, right? Now for white you have that condition that 9 into 8 minus 1, 17. Okay, up to 17. So you will have combination for 13. Okay, here because blue ball can be it should be 3 into blue ball. What is the condition? Blue ball was condition was 3 into 3 plus 1, 10 plus, right, from 10 plus. Okay, so when white will be 10, it can be 10, 11 and 12. Okay, I think so. Just check. Okay, wait a minute, I need to check again. Okay, if it is 3, 9 and 10, oh sorry, it is 10 to 16. Okay, because I am taking that as 17. Okay, then it will be 16, 15, 14, 13, 12. Okay, all the values. Okay, up to 17 you can take, right, because it is 2 into green minus 1. So up to 17 you can take, right, white up to 17 you can take, and the minimum it should start with 11, not 13 but 11. Okay, when you have 11 there will be one case. When you have 12 there will be 10 and 11 here, so 2 case. So when you have 13 white, you have 10, 11 and 12 for blue, that is 3 case. Similarly, up to 17 when you go, it is 10, 11 up to 16, that is 7 case. So 1 plus 2 plus 3 up to 7 is 28, sigma 7. Right, so we have already done this, so you can see that we will have 28 total possibilities, 28. Okay, so let's move to the next question on this set. And that is, what is the least possible total number of balls that can be there in all the bags together? Right, together we have already done this case that it was when red is 1, right, green 2 was not possible, right, because if green is 2, right, the number of white balls, which was 3 into 1 minus 1, 3 into 1 plus 1, that is 4. Right, maximum 4, sorry, it was, the possibility was 3 or minus 1. Okay, wait a minute, I need to check that possibility again. What was the case? It was for white it is 2g minus 1. White it is 2g minus 1, sorry. So white it is 2g minus 1, not in terms of r but 2g minus 1. So when you have 2g minus 1, that is 2 into 2, 4 minus 1, 3. So you cannot have blue here, right? So that case was not possible. So minimum possible was 1 when the green was 3, right? And 3 into 2 minus 1, 5 was this, 4 was this. So this was the minimum case which was possible, and the minimum number of total balls should be 13 then, right? It should be 13. Okay, this was your first set with 6 questions. Okay, once you solve that set,